Students, so we're on 7H now and coming right to the end of this unit of work, which is all about the skills of anti-differentiation and integration. And what we're going to look at today is just a particular way of questions being framed where they set up a result in the first part, which then we can use to find a tricky integral in the second part. So two examples. The first one you can see on your screen right now, and I'd like you just to have a go at it, see if you can find the connection between A and B, use your differentiation skills on part A, and then see if you can use those to help you with part B. Have a go, and then we'll go through it together. Okay, so first up, we're just doing differentiation, and hopefully we're feeling confident enough now with our skills to do the product rule in our heads. But as I differentiate y here, sine inverse is 1 over root 1 minus x squared. Remember that formula. And then I'm going to use the product rule on the right hand side here. I'm going to differentiate the x first of all and leave the second term the same. And then I'm going to leave the first term the same, the x, and differentiate the second term. And now I really need to think about it a little bit. I'm going to get a minus 2x, sure, from here. Then I'm going to get a half from the power, and then I'm going to bring the power down by 1. So I get this, and then just simplifying, so what is this first term? Well, this is 1 minus x squared to the power minus a half. And then I have a 1 minus x squared to the power a half. And then I have, well, the minus 2 and the half, they kind of cancel out, keeping it negative. And then I'm going to get an x squared, 1 minus x squared to the power minus a half. And then, slightly different ways to write this, obviously, depending on whether we use the indices or square denominator with square root like this. But we can see a common factor for these first two, and what we actually have there is 1 minus x squared times 1 minus x squared to the power the negative a half plus 1 minus x squared to the power a half. And if we add these powers, or we see how these interact, actually this is overall 1 minus x squared to the power a half to go with the other 1 minus x squared to the power a half. So overall 2 times 1 minus x squared to the power a half. Now why does this help us with part B? It's because this result here is very similar to the integrand that we're trying to integrate. And so we know what would differentiate to give us this, and this is so closely related to this that we can deduce what the result of anti-differentiation is for the integral we're given. So the integral we're given is a half times the integral between 0 and a half of 2 times 1 minus x squared to the power a half dx, always remembering our dx. And this result here, using part A, must integrate to sine inverse of x plus x times 1 minus x squared to the power a half. So if the red goes to the green when we differentiate, the green goes to the red when we anti-differentiate. Now, just to finish it off, we have the limits of integration here, the half and the 0, writing those top right corner like we know how to, and then substituting those in. Obviously got the half out front, half substitute in, I get sine inverse of a half, which is pi over 6. I can use my little triangle to remember that if I want, if I've got pi over 3 here, got a 1, a 2, and a root 3, and this angle is pi over 6. And then substituting a half into here, we have a half times 1 minus a half all squared, that's 3/4, so it's root 3 over 2. And then simplifying, we have pi over 12 plus root 3 over 8. And that is your final result. So I guess the key thing here is we use a little bit of differentiation from part A to find a result that then is connected to what we're trying to integrate, so we can work the process backwards. A similar, not quite so straightforward example here for number 2. I want you to have a go by yourselves, and then I'll go through it in a second. Okay, so part A, easy enough. We have y equals x e to the power 2x. So dy by dx is going to be using the product rule, differentiate the first, leave the second the same, plus leave the first the same and differentiate the second. So in other words, 1 plus 2x times e to the power 2x. Okay. Now, what makes this just ever so slightly trickier than before is that this kind of contains what we're looking for here, but it's not the whole thing by any means. And so, a little bit more tricky for us to work out. What we're actually going to do, or the way that I'm going to set it out, is I'm going to restate this as a equation in terms of an integral. So one way for me to do that is to say, well, we've just worked out that the derivative of x e to the power 2x is 1 plus 2x e to the power 2x. So what that means is x e to the power 2x is the integral of 1 plus 2x times e to the power 2x dx. And then what I'm actually going to do is I'm going to split this into two terms, because what I notice is that one of those terms is going to be related, so I need to remember my dx, is going to be related to what I've asked for in the question, which is the integral of x e to the power 2x. So this is what I'm looking for here. And so I can now try and rearrange this equation. So making this blue box the subject, that's going to be a half x e to the power 2x, take away a half times the integral of e to the power 2x dx. And then if I actually integrate this, which is a relatively easy thing to do, it's going to be minus a quarter e to the power 2x, because we need a half to cancel with the 2, and then plus c. And obviously I can factorize this out a little bit, but this will do for me. That's my answer. So, similar kind of structure to the first one, but we had this thing, didn't we, where we actually were able to split the result into two parts, one of which I can actually integrate and evaluate, that's the e to the power 2x, and the other bit is very closely related to what I'm asked for in the question. So, special note here about these types of questions, but the exercise you've got to do 2H is it's a combination of all the skills that we've learned so far, because very soon we'll still be going on with integration, but we're starting to be looking at it in a really applied context, and we, for the moment, just want to get these skills really, really sharp. So, best of luck with the exercises. Let me know what you find tricky.